Today, we're going to talk about prime factorization. Every composite number can be written as a product of prime numbers. Remember, a prime number is a number that is divisible by only one in itself. It has exactly two factors. The smallest prime number is 2. It's also unique because it's the only even prime number as well. 1 is not considered prime, but it's also not considered composite either. It only has one factor, not exactly 2. Composite numbers have more than two factors, so they can be divided by something other than 1 in itself. So let's take a look at the number 20. I can break down the number 20 because it's not a prime number. It's divisible by other things. Like, for example, I could take 4 times 5 to get 20. 5 is a prime number, so I'm going to circle that. But 4 I can break down some more to be 2 times 2. 2 and 2 are both prime numbers. So to write the prime factorization, I take the numbers that are circled, which is 2, 2, and 5, and I put multiplication in between, because what I'm doing, if I take 2 times 2 times 5, I get back to my original number of 20. But this isn't the best way to write it because I have more than one of the same term. So instead of writing 2 times 2, I could write 2 to the second power times 5. And that would be my answer. Okay? If I did, let's do 35. 35 can be broken down to 5 times 7. Well, 5 and 7 are both prime numbers. So my prime factorization for this would be 5 times 7. There's no exponents because they only are listed once, so that would be my answer. Another way that we solve these types of problems is called division by primes. So let's say, for example, we have the number, let's do 120. Okay? So 120, we do division by primes. This is sometimes called cake or the ladder method or staircase method. There's different names that people call this, but what we're doing is we're dividing by prime numbers. And I told the students 2 is the best one to start with because it's the smallest prime number. And then once you've exhausted 2, you can go to 3, and then 5, and then 7, and then 11, and however many higher you need to go in order to get your candle at the top, and I'll show that in just a second. This is an even number, so it is divisible by 2. So 120 divided by 2 would be 60. Well, 60 is still composite, so I'm going to divide it again by 2 because it is divisible by 2 again. That'll be 30. Well, 30 is still even, and so I'm going to divide it by 2 again in order to get 15. Well, now this is no longer an even number, so when I go to divide this one, I can't use the 2 anymore. I'm done with that, so I'm going to move over to 3. That gives me 5. 15 divided by 3 is 5. Well, 3 doesn't go into 5, but 5 does, and it goes in exactly once. There's our candle at the top. We have a 1 at the top. So it kind of looks like a cake, a big tiered cake. That's why we call it that sometimes. But what we've done is we've divided by prime numbers. These numbers right here are going to be our prime factorization. So we're going to use 2, 2, and 2, 3, and 5. So I've got 2 to the third power, because there's 1, 2, 3 of them, times 3 times 5, because there's 1 each of those. That would be my answer. I've told the students that they can choose either method, whichever one they like better. If they like division of primes better, or if they like the trees better. Does not matter to me. Just one or the other. And prime factorization is going to be this part right here, writing the answer as a product of primes. I hope that helped. Have a good day.